Dear friends, today we will discuss a problem on complex analysis. Okay. Let D denotes the set of all complex numbers whose modulus is strictly less than 1. Then there is an analytic function f from D to whole complex plane C such that f of 1 by n equal to 1 by n and f of minus 1 by n equal to 1 by n, where n is a natural number. Justify your answer. Okay. Okay. So before going to discuss the problem, first we state a result. Okay. Let omega be a open and connected subset of C, and f be an analytic function defined on omega. Now by the symbol ZF we mean the set of all complex numbers from the set omega such that f vanishes on the complex number, right? That means ZF is the zero set of the function f. Okay. Then the result is either ZF is identically equal to omega or the set ZF has no limit point in omega. Okay. The result is omega is a domain and f is an analytic function defined on the domain. Okay. And ZF is the zero set of the analytic function f. Then either the zero set is the whole domain omega or the zero set has no limit point in omega. Okay. And we will use this result to prove the given problem. Okay. First we define a function g from D to C by g of z equal to z. Okay. This is the identity function on the unit disc. Okay. Now we define another function h from D to C by h of z is fz minus g of z. Okay. Then the first observation is h is analytic on D. Okay. And the second observation is h of 1 by n is same as f of 1 by n minus g of 1 by n, right? So this is nothing but 0, right? The third observation is the point 1 by n belongs to the zero set of h, right? Since 1 by n goes to 0 as n tends to infinity and 0 belongs to the unit disc D. So by our previous result, zero set of h is identical equal to whole D. So this implies as fz is identical equal to gz on D. That is fz equal to z on D. Thus f of minus 1 by n cannot be 1 by n. Okay, and this completes the proof. Thank you.